Hi, everyone. Now, when we look at the relationship between the moon and the earth, there's some interesting facts that are important to us. One, there's actually a gravitational pull on the moon that affects the earth. How, you ask? We're talking about coastal tides. Now, let me explain this in the simplest way I can. You got the Earth right here and the moon right here. I've described this as a full moon because this is opposite the sun, okay? Where the moon is close to the Earth, there is a pull from the moon of a gravitational force from the moon that affects the Earth and, let's say, a body of water. That body of water is impacted by the gravitational pull of the moon, so that the moon is literally pulling the water toward it. Now, you say, but what about the fact there's gravity on Earth? True, but still, the closeness of the moon here is affecting the gravity, so it pulls the water toward it. I want to compare it to like a tug of war. Ever heard of a tug of war? It's where you have a rope and you have people on. It's a long rope, and one side has maybe 5 or 10 people pulling on it, and you got the other side has 5 or 10 people pulling on it, and they're pulling it back and forth, and they're pulling it back and forth, and the whole goal is to get one of those groups into the water and mud that's right between you. You're hoping and praying you can get them in the mud. Well, that's kind of what's going on here, even though we're not trying to get anybody in the mud in this case. What you have is a little bit of nip and tuck, where the moon is pulling on one side, but on the opposite side right here, where there is no moon, there's no moon over here because it's a full moon. The no moon side has the Earth's gravity pulling. So as a result, both sides are experiencing what's called a bulge. B-U-L-G-E. Bulge on one side caused by the moon, bulge on the other side is caused by the fact there is no moon. There's a bulge. Now, that's between the moon and the Earth. However, there's one other object that's thrown into this whole mix, and that's the sun. You see, that huge thing called the sun affects us all. And it affects tides in a very unique way. Watch. You got the sun right here. Now remember, I called this the full moon. Well, let's say I put this moon circle around and landed right here in the new moon phase. Okay? Well, we remember that new moon phase as being the place where the sun right here is bright right here and dark right here. Well, the angle is straight on for both. Both here for the new moon phase and the full moon phase. The sun is straight on. So what happens? There is a huge impact in terms of the gravity that affects the moon and the Earth when the sun and the moon are aligned like that. When it comes to being that kind of gravitational pull, you call this a spring tide. A spring tide on both sides here. Spring tide. Okay? Now, whenever this moon is starting to go back around like this, like it does, okay? About a quarter of the way through, it gets through 1/4. That is called, it becomes like a right triangle here, okay? That's a 90-degree angle, that's why it's a right triangle. At this point, it's going to be at the weakest spot, the weakest point in terms of the sun impacting the moon and the gravitational pull. So even though it has an effect, it's a lesser effect. This is called a neap tide. N-E-A-P tide. All right? Now, go back over here to the full moon, and you come back here to the three-quarter moon, and you have another neap tide, three-quarter, third-quarter moon. This also is a neap tide. It's the weakest part for the moon and the sun to affect the earth. Now, they're all impacting the earth in some way, and it's affecting the water bodies in some way, but they're doing it differently depending on the location of the moon and the direction of the sun and the impact of the gravity of the sun on both the earth and the moon. Now, I know it's still maybe a little confusing, but all you gotta do is think of this. The moon, when it goes around the earth, it pulls on the earth as it goes around. And as a result, the gravity is what affects the tide. When it's the opposite side of the on the opposite side of the earth, the gravity is less. When it's on where the moon is, the gravity is more. Okay? Same with the sun. When there's a direct line to the sun, the gravity is more. When it's not a direct line to the sun, the gravity is less. Now, I know, I can still see, I can see you. You're looking at me like, I'm getting it, but not completely. Well, we'll talk more about this. Let's just call this part 1. Okay? Your teacher's coming. I know your teacher's got even better answers. Later.